So in this example, we're going to talk about graphing the curve whose parametric equations are given and show its orientation. All right. In other words, we're going to show the direction of movement. And also we're going to want to find a rectangular equation for each curve. Right. Now, a lot of times for some students, finding the rectangular equation first can be easier for them, and we can certainly do that. So if we look at what we have here, solving for t with y will be relatively straightforward, that we could say that t is equal to 5 minus y. So that means that x is going to be equal to 2 times 5 minus y squared plus 6. Now notice it just says to find a rectangular equation, and that's a satisfactory rectangular equation. It doesn't ask us to do it in standard form, right? So we're fine being able to know that, hey, that's going to be the equation of a parabola, and it's going to happen to be the equation of a parabola, and we could be able to determine whether it opens left or whether it opens right. But we can always also use a table of values to help us with plotting our information. We can always use a table of values to help us plotting our information. Right? So we could come over here and say, hey, I noticed that I have some symmetry and I noticed that I have my y value. And so I might say a value for t, right? And I might come over here and say, hey, a value for t with the 5 is probably going to be valuable for me because that's going to give me an x and it's going to give me a y, right? In particular, a value of 5 will give me a y value of 0, which is useful, right? And for x, it's going to be, right, 2 times 5 squared, so that's going to be 50 plus 6, that's going to be 56 for x, right? Then we might look to choose another p-value, and we might say, well, let's consider positive 6 and negative 6 because those would be, or not positive 6 and negative 6, excuse me. Let's do positive 6 and positive 4 because that would give me one above 5 and one below 5. So for the y values, 5 minus 6 is negative 1, and 5 minus 4 is positive 1. Right? And for the x values, I would have 2 times 36, so that would be 72, plus 6, that would be 78. And I'd have 4 times 16 plus 6, so that would be 32 plus 6, and 32 plus 6 is going to be 38. Right? And I could go through and do the same thing for a few more values, and maybe I do values that are, going down to 3, 2, 1, and 0 for t. All right, that's fine. All right, so if t is 3, 5 minus 3, t is 2, 5 minus 2, t is, what do we have here? T is 1, right, 5 minus 1, all right. T is 0, that'd give me a 5 there, right? And then, of course, 3 squared is 9. 2 times 9 is 18, plus 6, that's 24, right? And I have, let's see here, 2 squared, that's going to be 4. 2 times 4 is 8. That's going to be plus 6, 14. 1 squared is 1. All right, that's going to be 8, and 0, that's going to be 6. So I have a variety of numbers. I've got a variety of numbers that can kind of help with my values here, with my x values. And of course, if I went on to -1 and to -2 and to -3, I could have my y values and my x values. And I should notice that something squared is going to set this up so that I would have 8 and 14 and 24, right? And with the y values, 5 minus -1, right? And 5 minus -2 and 5 minus -3. So now I might be able to draw my graph a little bit more easily. And I can see some x values and I can see some y values. And in fact, I might say, hey, maybe, right, maybe I use these values and the symmetry that's present in these values to help draw my graph. Okay, so I can see my y values move upwards and I can see my x values. So I might set this up so that I say, hey, I'm going to have, right, my axes down here, right? And let's see, from these, I have the smallest x value is 6, and that is at a y value at 5. So the smallest x value is 6, y value at 5. So I'll say 1, 2, 3, 4, 5, 6, 7, 8. Right, so at a y value at 5, I'm going to say an x value of 6. So I'll say that there's x value of 6. And then x value of 8, so just a little bit further, x value of 8, and that's going to be with a y value of 4 and a y value of 6. So I might say here and here, right? And then 14, right? Then I have 14 on a y value of 3 and a y value of 7. So 14, maybe that's here, and 14, maybe that's there. And then I'm going to have 24, right? Then I'm going to have 24. And so let's say that each tick mark is 4, right? Let's say that each tick mark there is 4. So that's 4, 8, right? So there would be 16, right? And we would say there would be 24, and we have 24. So I'll come over here, I'll say, hey, I've got a point up there, and I've got a point down here. And notice that for t values, going from negative infinity to positive infinity, so I would start at y is positive 8, x is 24, so I would start up here and travel in the direction to down there with an x value of positive 24 and a y value of positive 2. So my direction of travel is actually the parabola moving in this direction, right? And I know the direction of travel and that I am coming from the negative infinity values of t and then going around right through point A and continuing to go around through point B. But I have those going on infinitely. So there is my graph of a curve with the given orientation. Okay. If I look to my next equation, I have an equation that should look familiar. I have an equation that should look familiar, right? And if I look at this equation, I should recognize that this is a hyperbola, right? And I can always solve for this, of course. I could always solve for this. Say that x plus 4 is equal to the tangent of t, and be able to say that y minus 5 over 2 is equal to the secant of t. And we recall that 1 plus the tangent squared of t is equal to the secant squared of t. So that means that the secant squared of t minus the tangent squared of t is equal to 1. So what does that tell us? That tells us that y minus 5 all over 2 quantity squared is equal to, whoops, no, not equal to, minus x plus 4 quantity squared is equal to 1. So we know that we have a hyperbola, and now we need to graph it. Where is the center of our hyperbola? The center of our hyperbola is at negative 4, positive 5. So I'm going to say there is the center of my hyperbola at negative 4, positive 5. We'll say that that is my center. Okay. Now, I have 2 as my denominator, that when squared I would get 4, but I know that 2 units above and 2 units below my center are going to be the vertices for my hyperbola. So I'll have a vertex there and I'll have a vertex there. I also know that 1 unit to the right and 1 unit to the left I am going to have my setup that allows me to draw a box, that allows me to draw my asymptotes. Right, so I have my asymptotes that I can draw in, and along those asymptotes, my hyperbola is going to follow. So I've got my hyperbola following those asymptotes that we drew in. Now, for this particular problem, we just ask you to graph. For this particular problem, we just ask you to graph. And we need to make sure that from our graph, we can tell the major information. So that would mean that our center is clearly identified. And that center is going to be -4, +5. Also that our vertices are clearly identified. So that's going to be vertex 1 going up 2 units. So that'd be -4, +7. And vertex 2 going down 2 units, which would be, if we go down 2 units, that would be -4, +3. And then our asymptotes, for our asymptotes, we know that this distance to the vertex is 2. And the distance to the side is 1. So that tells me that my equation for my asymptotes is going to be y minus my y value is going to be equal to plus or minus the slope of the asymptotes, which would be 2/1, and then x minus my x value. And there I have my asymptotes. So now I've drawn my graph and included my asymptotes, everything that I want to have. Okay. And last, certainly not least, find a set of parametric equations for an object that moves counterclockwise along the ellipse, and we're given the equation of the ellipse. So important to remember that we have x equals cosine of t, all right, and I'll come over here and say a cosine of t plus h, y equals b sine of t plus k will be an ellipse, and this type of ellipse will go, not clockwise, excuse me, this type of ellipse will go counterclockwise. Whereas x equals a sine of t plus h, and y equals b sine of t plus k, this would be an ellipse that rotates clockwise. And both of these are going to be centered at h comma k. All right. So for us, if we want a counterclockwise ellipse with our given values, all right, if we want a counterclockwise ellipse with our given values, we need to be able to identify, the form that we're going to use. And we've said, hey, I know I want counterclockwise, so this is the form I want to use. All right, and if I consider that form, that's x minus h all over a is equal to the cosine of t, and y minus k all over b is equal to the sine of t. So therefore, the equations that I want, that are the parametric equations to move counterclockwise along my ellipse, will be x equals 25, all right, x equals, let's see here, no, because we're going to have the square pieces. So we're going to have this squared equals cosine squared, and this squared equals sine squared. So that means that a squared is 25 and b squared is 36. So that's going to give me x equals 5 cosine of t. Let's see here, center is at 3, so plus 3. and y equals 6 sine of t plus 4. And we always have to make sure that we discuss our parameter. So we might say that, hey, our parameter for t, let's let it be all real numbers. So this is just going to be an object that moves counterclockwise along the ellipse forever and ever. And that's it for these. All right, so make sure if there's any particular piece that doesn't quite make sense that you get that clarification. Right, so quite a bit of information. Please make sure that you get the clarification as needed.